Hello everyone, my name is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So in a series of lectures delivering for a subject microcontroller and embedded systems design having code KEC 061, what we have covered so far, we have completed unit number first and second, and after that we have left with some portion of the unit 3, that is remaining portion of the ARM processor. So in the previous two lectures, part 1 and part 2, we have completed most of the things of ARM processors, like ARM families of series of architectures, ARM Cortex M4 architecture, what are the applications of ARM, what is the difference between ARM processor and architecture. In previous lecture we have covered. So in this lecture we will cover the remaining portion of the ARM Cortex M4 architecture. So these are the table of contents we will see in this lecture. Just a second, I am taking the marker. These are the table of contents we will see in this lecture, we will discuss in this lecture. Distinguish the different blocks of ARM processor, we will see the block diagram here. Okay, what is the block diagram of ARM processor? So in the previous lecture we have seen the architecture of ARM. In this lecture we will see the detailed description of block diagram of ARM processor. After that, what are the ARM processing modes available, we will see here. Registers in ARM Cortex M4 processor, we will see what are the various types of registers available in ARM Cortex M4 processor. After that, we will see the some board example, we will take some board example to know more about the ARM processor. Okay, these are the table of contents. So let us start with the first slide, that is ARM block diagram. Okay, so basically ARM, we know that ARM basically stands for advanced RISC machine. So advanced RISC machine, that it has RISC architecture, it is of 32-bit, unlike other 8051 microcontroller, it is of 8-bit. So other microcontrollers are also available like 8052, it is of 16-bit, but ARM is of 32-bit. It has a high processing capability as compared to other microcontrollers. So in this block diagram, this is basically a chip, ARM processor, okay, Cortex M4 processor. So ARM M4 processor is basically microcontroller. So the function of microcontroller is that all the things are integrated on the same chip. So this is basically a SoC, system on chip. So we are integrating the entire system. Entire system means it has a memory unit, it has a peripheral unit, and it is also have set of registers, it has a timer, all the things are integrated on the same chip. So what are the various blocks available here? It has a nested vector interrupt controller, it has a floating point unit, it has a flash patch breaking point unit, it has a memory protection unit, it has a data watch point unit, it has access port unit, it has a bus matrix, it has an instrumentation trace macro cell unit. So these all the units are integrated on the same chip. So in addition to the integrated unit internal architecture, there is some external units which are connected to this processor, like it has an interrupt and power control unit, that is a wake up microcontroller unit. It has a JTAG interface for debugging operations, JTAG operations, JTAG means joint test action group. It is basically hardware and serial protocol. It is connected externally to the ARM processor. It has a I-code unit, instruction interface, it has a data interface unit, it has a system interface unit, and there is trace port interface unit as well. This is embedded trace macro cell unit. So there is some internal units and external units available in ARM block diagram. Let us see its explanation. So nested vector interrupt controller is basically vector means that it has a in ARM Cortex there is a interrupt execution. So what is the meaning of interrupt? If you are doing anything, normal execution, some obstacles, some external signals are coming, so it will disturb the normal execution, normal sequence, and what is doing there, microcontroller will stop the normal execution, save the content into the program counter, and start executing the interrupt which has been come in between the main execution. Okay. So vector means that every interrupt which is coming into the ARM processor, it has some vector address. Okay. It has a Cortex M4 processor, floating point unit to execute floating values, floating numbers. It has a floating point unit which can carry floating operations. Flash patch breaking point unit. Okay, it has a memory protection unit, memory management unit, we can say. How the IP library is executed into the SoC chip, whether it is of RAM, ROM or flash, it is mentioning by the memory protection unit. It has a watchdog and watch point and trace point unit, not a watchdog. It has a access port. Access can be taken place through this unit. Okay, bus matrix unit, how the bus will be carried out. So it is connected to the data interface and a system interface. Okay, it has a ROM table as well. Okay, it has a instrumentation trace macro cell units. All under this there are various types of IP libraries available. Okay, it has embedded trace macro cell. It is directly connected to the data watch point, etc. It has a trace port. What is the tracing means? What currently execution take place? It is carried out by the trace unit. It has a JTAG interface for debugging operation. It has a wake up interrupt controller unit. Okay, so various types of blocks available in the Cortex M4 processor. So these are the processor features. So this diagram represents the we can say that complex view of previous diagram. Okay, so basically this is ARM Cortex M4. This diagram is taken from the ARM Cortex company manuals. Okay, so this is it has a nested vector interrupt controller CPU. It has a enhanced DSP processor. It has a code interface, memory protection unit, SRAM, bus matrix, floating point unit, wake up interrupt unit, data watch point, debug interface unit, serial wire unit, ETM, ITM, flash patch. All the things are integrated on the same chip. So basically it is a single chip, or we can say that system on chip. All the system, entire computer is integrated on the same chip. So key features of this processor is that it is of 32-bit RISC processor. It has a 32-bit instruction set. Okay, it has a 37 pieces of 32-bit integer registers. So each register is of 32-bit. Okay, so out of 37 pieces, only 16 registers are available for our execution, for the operation of the ARM processor. Okay, it has a pipeline structure. So there are 3 stages of pipelining, that is a fetching, decoding and execution. We have seen in previous lecture as well. Okay, it has a cache memory unit. Cache means the fastest and memory unit available in our ARM processor. It is based, it is based upon the von Neumann type of bus architecture. Okay, von Neumann means that both the program and data memory are allocated in the same memory space. Main memories both have a same data bus and a program bus. Okay, same allocation for that. So ARM7, these are the classic processors we have seen in our previous lecture, that ARM7, ARM9 and ARM11. So ARM7 utilizing the von Neumann memory and ARM9 utilizing the Harvard memory. Okay, so these are the more processor features. It has a 8, 16 or 32-bit data types. Okay, it has a 7 modes of operation: USR, FIQ, IRQ, SVC, abort, ABT, system, SIYS, UND. We will further slides we will see the more explanation of these modes of operation. It has a simple architecture. So it and reasonably good speed, power consumption ratio. Basically ARM has a simple architecture, it has a ease of access, and it has a highest speed of execution as compared to other processors. It has a processor cores available like ARM6, ARM7, ARM9, ARM10, ARM11. We have seen that. Extension means that along with the thumb and instruction and ARM instruction, it has a JEGL instruction set available. JEGL means that to execute Java directly, we have to utilize this type of instruction set. It has a IP blocks as well available. IP blocks like UART, GPIO, memory controllers. These types of IP blocks available in our microcontroller, ARM processor. It has a 32-bit RISC processor. This is basically a RISC. It has a 32-bit RISC processor. Okay. it is capable of executing 16-bit instructions, von Neumann architecture. It has a high density code available in ARM processor, large number of IP libraries available, and out of that IP libraries, ARM holding company has the variety to manufacture different ARM processor families of processors. Okay. It has a thumb set 16-bit instruction allows to approach 65% of the standard ARM code while retaining ARM 32-bit processor performance. So, it has a thumb instruction set also available in our processor. Okay. So, more features are is that smaller die size because it is small in size. In single IC many processors are available. Okay. Okay. So, it has a 72,000 transistors. These 72,000 transistors are integrated on the same chip. Okay. It occupying only about 4.8 mm square in a 0.6 micrometer semiconductor technology. So, basically these are the dimensions for particular any processor. Okay. It has a low power consumption. The key feature of microcontroller ARM processor is that it has a low power consumption as compared to other processors. So, it is dissipate about 2 megahertz with 0.6 micrometer technology. So, it has a memory access available, that is 8-bit, 16-bit, 32-bit. So, we have seen in previous slide that data available as a 8-bit, 8-bit means 1 byte, 16 means half word means 2 byte, 32-bit means 4 byte and 1 word. So, 1 word is equals to 32 bit. Okay. It has a memory interface unit like SRAM, ROM, SRAM, DRAM, flash memory available. It has a 4 basic memory cycles. So, memory cycles are available as a idle memory, sequential memory, non-sequential memory and the coprocessor memory. These are the 4 basic memory cycle available in ARM processor. Idle mode, sequentially executing the data, non-sequentially, coprocessors mean that main processor is divided into a various coprocessor etc. All are executing the same instruction. So, these are the ARM processor mode. In the first slide we have seen that there are 7 basic operating modes. Okay. 7 these are the modes available. This colon represents the different modes of operation of ARM processor. Supervisor mode, FIQ mode, IRQ mode, abort mode, undefined mode and a system and a user mode. So, this white portion represents the exception modes. Exception means that these are based on the exception model. If any interrupt occur, exception model can be utilized. And there are 2 categories of mode along with the 7 mode of operation. There are 2 categories, privileged mode and unprivileged mode. So, out of the 7, 5 modes are belongs to the privileged mode and rest of the 2 mode, that is system and user defined, are belongs to the unprivileged mode. So, let us start with the description of each mode. SVC means supervisor mode. Supervisor mode means that when it entered on reset and when a software interrupt instruction is executed, this will be activated. So, basically when you are doing supervisor mode means when you have reset the system or you are executing the software interrupt instruction, this type of mode will be utilized. It has a FIQ mode. FIQ means that it has a when it is when the microcontroller ARM processor entered into the FIQ mode, then it has a highest priority as compared to other modes, that is interrupt is raised. So, FIQ means it represents the pointer to the particular type of interrupt. IRQ means that when our ARM processor entered into the IRQ mode, then it has a low priority, it indicates the low priority. Okay. Abort mode means abort the operation, stop the operation. So, when our microcontroller ARM is entered into abort mode, then it is used to handle memory access violations. So, it will not work. Okay. We are stopping the operations of the ARM processor. It is undefined mode, used to handle undefined instructions. If ARM processor carried out the undefined instruction which did not have any type of command, then it is comes into the category of undefined mode. It has a system mode. System mode means that when our ARM processor utilizing the system mode, then this privilege modes using the same registers as a user mode. So we are utilizing the same registers when our ARM processor is utilizing the system mode. It has a user mode. User means that mode under which most applications task can run. So user mode means that when the ARM processor go into this mode, all the applications, most of the applications are utilizing through the ARM processor. Okay. So this is the explanation of the 7 basic operating mode. So now let us start with the registers in an ARM Cortex M4 processor, because in our syllabus only we will study only the ARM Cortex M4 processor. We have seen its features. Now what are the various types of registers available? So we have seen that registers are used to hold the values. It may be on the temporary basis or permanent basis. So basically in microcontrollers 8051 we have seen that two types of registers available, that is the general purpose register GPR, and another one is the special function register SFR. Two categories of registers available, and we can execute the instructions on a temporary basis and on the permanent basis. Okay. So in our ARM is basically a 32-bit processor. It means that it can carry out 32-bit instructions at a time. So ARM has basically 37 registers. So out of and each register, it has a 37 register, and each register is of 32-bit. Okay. All so out of 37 registers, what we are using here, out of 37, one is dedicated to the program counter. One register is used specific for program counter. One is dedicated to the current program status register. We will see the explanation of these types of register in our upcoming slides. After that is a 5 dedicated saved program status register SPSR. Okay. It has a 30 general purpose registers. So out of 37, 30 general purpose registers are available. And we have left with 7 registers. 7 is dedicated to special function registers like program counter SPSR and SP and CPSR, etc. So each mode, we are talking about the 7 mode. Each mode can access R0 to R12 registers, R13 registers, R15 and R14, etc. So what is happening is there, out of 37 registers, we are talking about the 16 registers that is used in our ARM processor. Okay, I am erasing the rest of the things in this slide. So out of the 37 registers, each of 32-bit, I am summarizing the things here, we are using 16-bit registers, and out of these 16-bit registers, 13 R0 to R12, 13 total 13 registers is utilized for general purpose register. They have a general function. They are available as a user to the general functions. Okay, they are the general purpose registers, and from R13 to R15, that is R13, R14 and R15. These are available as a special function registers. Okay. So we are left with 3 registers. R13, it is dedicated to the stack pointer, R14 is dedicated to the link register, and R15 is dedicated to the program counter. Okay. And one another registers, okay, out of the 16 we can say that another register, one is utilized for CPSR, current program status register, and one is utilized for the SPSR. They are this is basically a privileged registers. Okay. So this diagram represents the categories of the registers. These are the current visible registers, R0 to R12. These are the general purpose registers, and these are the special function registers. Okay. Special function means that this is available for some specific task only. This do not have any general function, and general purpose register means that any value can be saved. These are used for general purpose. Okay. So general purpose R13 is dedicated to SP, R14 is dedicated to link registers, R14 is dedicated to PC, and 2 registers are dedicated, one for each for CPSR and SPSR. Okay. So different modes, we have talking about the different modes, user mode, FIAQ, SVC, undefined, all the are accessing the registers of this our ARM processor. For example, abort mode utilizing all the registers of the ARM processor, user defined utilizing the R13 and R14 of the ARM processor registers, FIAQ mode utilizing the R8 to R14 registers, IRQ utilizing the R13 and R14 register, SVC supervisor mode utilizing the R13 and R14 register, undefined mode utilizing the R13, R14. So we are changing the R13 and R14 register according to the particular mode, and according to that particular mode, R13 and R14 values are changing. Okay. So this belongs to SPSR. Okay. All belongs to SPSR. Okay. And this belongs to CPSR. Okay. So this is the register organization of ARM Cortex M4 architecture. So let us see one by one. Program counter. Program counter is R15 dedicated to program counter. So program counter is basically is used to point out the address of the next instruction to be executed by the processor. If any processor, if we are doing programming, then a particular step, if you want to execute next instruction, its address is is mentioned by the, is point out by the program counter. Okay. After that, link register, LR means link registers, it stores the return address of the registers. Return address is stored by the link registers. So saves a copy of PC, saves a copy of PC. After the program counter instruction, there is some output value, and this is the return address, and it is stored by the link registers. So executing the BL instructions, subroutine call, etc. So basically LR register is used to store the return values of the program counter. It is copied back to the PC after the return values subroutines has been executed. Stack pointer, R13 is dedicated to stack pointer. So what is the meaning of stack pointer? It is used to point out to the top of the stack. So stacks are basically a memory location. This is top location, this is bottom location, and top of the register bank is specified by the stack pointer. So there is no stack in the ARM architecture. Okay. So we can say that stack pointer is used to point out to the top of the stack registers. CPSR means current program status register. It holds the current program values, that is the visible status registers, though it holds the value of the visible status registers. SPSR means saved program status register. It holds a copy of the previous status register. It did not, it only stores the copy of the previous status register. It did not execute any current execution. The current execution is not taken place in the SPSR. Okay, while executing exception or interrupt routines. So what is happening here? SPSR, it is copied back to after execution, all the values will be back to the CPSR. Okay, and no SPSR available in user or system mode. So SPSR will not hold any value. After execution of the SPSR, values will further be provided into the CPSR. Okay. So this is the summary of these registers. Below, above this line, there are thumb state low registers, and below this there is a high registers available. So these are the modes we have seen so far, that these are the modes. Okay, and each mode is utilizing some registers. Okay, so these are the summarization. You can see that different registers are utilized by the different modes. So how the organization can be done in 32-bit register. Here you can see that 32-bit register is divided into a various register: F mode, S, X and C. Okay. So we can see that each from 28 to 31 there is some flag values. Okay, negative flag, Z flag, carry flag and overflow flag. So the flag has raise, or raise means 1, or low according to the its operation. So for example, if negative result is occur, this flag will be 1. There are interrupt disable flag available here. I means interrupt, its value may be 1 if we are disabling the IRQ mode of operation. It's F means that it is value is 1 when we are disabling the FIQ. T means that thumb mode only, it is used for thumb mode only, T. So, thumb mode means that it is, if its value is 1, then we can say that we are using the thumb state. If it is value is 0, then we are using the ARM state, because there are two types of instructions available. Okay. So, other modes available, these are the undefined bits from 7 to 27 undefined bits available. So, FIQ, these are all modes have particular set of value. For example, if we are using 1000, it is of user mode. Okay. So, we are summarizing here. R15 dedicated to program counter. We have seen that program counter used to point out the point out to the address of the next instruction to be executed by the processor. Okay. So, when we are executing the thumb state, what we are doing here, the execution after execution of the PC value, its PC value is stored into the 1 to 31 means that 32 bit undefined state. All the values is of the all the values of the program counter will be stored into this mode. Okay. So, all the instructions are taking place through these registers. This is the register organization. In the last topic, we are doing the exception handling. Exception means that which has a exception model. That means that interrupts, not a normal execution, we are handling the interrupts. So, this is the instruction exception model. Here it is we are mentioning all the modes of operation, FIQ, IRQ. This is for reserved data abort, prefetch, abort, software interrupt, undefined instructions. All the things are copying here. So, when the exception occurs, when the exception means when the interrupt occurs, the ARM will stop its current execution. It is entered into the SPSR mode. After executing the SPSR mode, its value will further return into the CPSR. Okay. And after value is returned, it start to execute its normal execution, which has been staved into the program counter, like what we have done in interrupt. So, the function of exception handling is similar to the interrupts which we have we have studied in 8051 microcontroller. Okay. So, it has a 3 modes of operation, ARM7 TDM, fetching, decoding, executing. If we are looking into the advanced pipelining concept, advanced architecture, ARM7 support 3 stages of pipelining, and ARM9 is support multi-stage pipelining like fetch, decoding, executing, memory and write. So, fetching, decoding, executing, fetching the instruction, decode it and executing, implementation of the instruction carried out in ARM processor. So, in the last slide we have seen that one of the example of ARM board. This is the picture of the ARM board available. You can see different types of blocks, USB block, Ethernet, boot mode. This is the ARM processor, GPIO ports, touch panel, camera interface, all the things are integrated on the same chip. So, basically this is SoC, system on chip. Okay. So, thank you everyone. I have hope you have enjoyed my lecture. So, we have completed all the things of ARM processor. Thank you everyone.